So, very good afternoon, one and all. I welcome you all for the series of
Good
dynamic.
morning, sir.
Today we have with us again Professor Faisal Hussain sir from Vision College of Engineering in Nagpur. So, over to you, Faisal sir.
Okay, thank you, sir. Good afternoon, students. Am I audible?
Yes, sir.
Okay, so welcome you all in this GATE lecture series, Prerna scheme, sponsored by AICT, Government of India. So today we will cover two topics. One topic will be your dynamic force analysis, dynamic analysis for linkage of mechanisms, and second will be the flywheel. So within the 2 hour span we will complete these topics, and if the time will permit we will also cover some part of a governor rule. Okay, so let us start the topic. I am presenting my screen. Okay, so welcome you all for the GATE lecture series. Today's topic is related to dynamic analysis of linkages first, and then we will go for switch to the flywheel. So let us see the contents of dynamic analysis of linkages that we have to cover. The contents are like this. Screen is visible to you, students?
Yes, sir.
Okay. So let us start. Please unmute yourself, other students, please. So the contents are like this. First, we will go through the introduction. Then we will see the integral concept related to determination of force and couple of a link. Then we will see what is D'Alembert's principle, where how it is applied, where it is applied, and what is the reason of application of D'Alembert principle behind any mechanism. Then types of force analysis, then dynamic analysis of 4 bar mechanism. I will just go through the basic steps related to graphical, because generally if you are going for an optimal design, the graphical approach is difficult. There is some disturbance. Please unmute yourself.
Jain
Then
sir, are you hearing me?
Yes, sir.
Okay. Mute your mic.
then dynamically equivalent system. Then what do you mean by 2 and 3 force member? Then what is the basic concept of center of percussion? Then the most important topic, that is the approximate analytical method for determining velocity and acceleration of the piston. Then the force analysis of reciprocating steam engine. Then the last part will be your straight line mechanisms. So these are our contents. So let us move. Now introduction. Basically, dynamic force analysis includes the inertia force effect. As we all know that the accelerating force and inertia force both have same magnitude, but their direction is opposite. The inertia force will always act opposite to the direction of accelerating force. So, in dynamic force analysis, we have to consider the effect of inertia forces along with the externally applied forces. So, in a mechanism or in a system, there will be some external applied force which are acting at the joints at different points, and with that we have to also consider the inertia effect while solving the dynamic force analysis problems. Now, if inertia force is considered, then the question rises that, sir, what is inertia force? So, inertia force is your imaginary force, which when acts upon a rigid body, it brings, sorry, it brings the body in a equilibrium position and it opposes the accelerating force. How it opposes the accelerating force? It acts opposite. For example, a body is placed on a horizontal surface and body is moving towards right, then inertia force will move toward left. It will oppose. So accelerating force is mass into acceleration. Inertia is also mass into acceleration with a opposite sign, that is negative sign. Then inertia torque. Inertia torque is also a imaginary torque. And when it is applied on a body, the body is your rigid, the body comes under a equilibrium position. And this inertia torque opposes the accelerating torque during the angular movement, angular displacement. This inertia torque will be developed. So, what is the use of dynamic force analysis? So, basically, what happens? Dynamic force analysis means that when complete motion of a system is known, then what we have to do? We have to find out the unknown joint forces in the mechanism and attached to it, we have to also calculate or find the external applied forces, then your applied couples, applied moments, applied torque, which causes the system to move in the manner prescribed. Manner prescribed means if it is a single slider crank mechanism, input is your crank and output is your rocker. So now tell me what will be the motion prescribed in a crank rocker mechanism. Input and output motion prescribed in a crank rocker mechanism. Please, any one of you students, please tell me what will be the prescribed motion of a crank rocker mechanism. Can anyone give the answer, please? Okay. As we know that the crank will rotate through a full rotation and the rocker will oscillate from certain prescribed maximum to minimum position. So the motion prescribed will be rotary motion, which is converted into oscillatory motion. So that is the motion prescribed. Rotary motion is converted into your sliding motion, not oscillatory motion. Oscillatory will be in your 4 bar. In single slider, it will be rotary motion converted into linear motion. So that is the motion prescribed. And in 4 bar, it will be rotary to the oscillatory motion. Because in a single slider, it will be a crank and piston mechanism or a crank and slider mechanism. Okay, not crank and rocker. So basically, we know degree of freedom, independent coordinates required in a system, that is your degree of freedom. So single degree of freedom means if the freedom of movement is in one direction and by one body. So, in single degree of freedom, what happens? One component of externally applied forces can be independently found out in single degree of freedom. Generally, in multi degree of freedom, what happens? Number of forces externally applied can be found out. So, basic concept is that when complete motion of a system is known, we have to find the external forces, couples and moments, and for that purpose dynamic force analysis is useful. Now let us see here, this is a rigid body as shown in the figure, and what we are doing, we are determining the forces and coupler of a link. Okay, we are determining the forces and coupler of a link. So in this rigid body, first of all, let us consider the centroid is G of this body. Similarly, from this centroid, let us consider two forces F1 and F2 are acting in such a way that their magnitude is same but they are in opposite direction. Similarly, let F be your resultant. F be your resultant force acting on the rigid body, and let M be the mass. So in a rigid body is having a mass M. From the centroid, two forces are passing, F1, F2 equal in magnitude, opposite in direction, and there is a resultant force which is displaced at a distance of h from the CG. So generally what will happen, as F1 and F2 are same, okay, they might be in opposite direction, but this F1 and F2 forces are same. Okay, F1 and F2 forces are same. So they can be cancelled out without affecting the equilibrium of the link. Directly they can be cancelled out because of the equal magnitude. Thus, a single resultant force which is represented by F and whose line of action is not passing through the centroid G. So this resultant force, the line of action is like this. This is the line of action of this resultant force. It is not passing from the CG. So this resultant force F is very much capable of producing linear and angular acceleration of CG of the link. And also this F and F2 forces, this is your F and this is your F2. This F and F2 will form a couple. They will form a couple. And this, as it forms a couple, the torque which will be induced in it will be F into H, force into distance. It can be represented as I into alpha, and it can also be represented as mk square into alpha. Alpha is your angular acceleration, k is your radius of gyration, m is the mass of the body, I is the mass moment of inertia. So this is the equation through which we can determine the force and couple and torque also on a link. Now let us go to the D'Alembert principle. What is D'Alembert principle? It says that the vector sum of forces and torques, couple is also incorporated in it, has to be 0. Generally, D'Alembert principle is applied when the resultant forces which are acting on the body plus the effective forces, these are your inertia forces, all these forces, all the summation of the forces, and the condition is in equilibrium. Generally, it is used to reduce a dynamic problem. D'Alembert principle is used to reduce the dynamic problem into an equivalent static problem. So, for converting dynamic problem into an equivalent static problem, D'Alembert principle is employed. And in simple terms, all the forces acting on the body together are in equilibrium, and if they are in equilibrium, then the summation of all the forces will be equal to 0, summation of all the torque will be equal to 0. So this is the D'Alembert principle. Now let us move to the types of force analysis concept. So in types of force analysis, the first is your equilibrium of members with two forces. It means in a system two forces are acting. Second is equilibrium of members with three forces. In a system, three forces are acting. For example, trusses. Equilibrium of members with two forces and torque. Two forces are acting and also torque is there. Similarly, equilibrium of members with two couples. In a system, two couples are acting. Similarly, equilibrium of members with four forces. In a system, there are four forces which are acting in any quadrant in any direction. It may be a non-coplanar, it may be non-collinear. So this is the force analysis concept. Let us briefly go through the graphical method, but as I have told you that for optimal design, graphical approach is difficult. Why it is difficult? Because if you want to find the accelerations, if you want to find the uh, external forces, if you want to find the torque acting on a link, it is very difficult if we are going through the graphical method, because for graphical method we have to consider the crank angle. Okay, for example, we will consider crank angle at 30 degree or 20 degree or 45 degree, that is theta. So for that crank angle we will get the output. Okay, so if you want to find the torque when the crank angle is 60 degrees, so for that purpose we have to solve the numerical from configuration diagram to velocity polygon to acceleration polygon to free body analysis to your final answer. So dynamic analysis of any mechanism, it may be a 4-bar or a single slider mechanism, it is very difficult. The optimal design is very difficult. Okay, you have to, for every degree you have to draw the graphical method. So we will just go through the points. Our basic thrust will be on analytical method of single slider mechanism, which generally comes in the gate papers. Now the first will be, if we are going with graphical method, first we have to draw the velocity and acceleration diagram of mechanism with the help of space diagram. Then we have to determine the linear acceleration and angular acceleration of the system. The third, we have to find the inertia and inertia couple, inertia forces, inertia couple by using the relations Fi equal to minus Ma and Ci equal to minus I alpha. M is the mass, A is the linear acceleration, and Fi is your inertia force. Ci is your inertia couple, I is the mass moment of inertia, and alpha is your angular acceleration. Then we have to replace the inertia force Fi with an equivalent offset inertia force in such a way that we have to take the Fi and Ci value into consideration. And the last will be that by assuming equivalent offset inertia forces on links as a static force, that is the equivalent system concept, we have to analyze the mechanism. So this is the process of four link mechanism. Now let us go to the concept of equivalent dynamical system. What is equivalent dynamical system? Let us, for example, if we want to interchange the body in such a way that the inherent geometrical motions would not get disturbed. So at that point, we will consider the equivalent dynamical system concept. What the system says that, for example, see this figure. What we are doing? We are replacing one link in such a way that the sum of their masses is equal to the total mass of the body. The center of gravity of the two masses coincides with that of the body, and sum of masses, that is the mass moment of inertia about the center, should be equal to the mass moment of inertia of the body. If in a system these three parameters, first parameter, sum of their masses is equal to the total mass of the body, that is m1 plus m2 equal to m. Similarly, the center of gravity of the two masses coincide with that of the body. And the third is the sum of the masses, mass moment of inertia about their center, one minute, mass moment of inertia about their center is equal to the mass moment of inertia of the body in the front side. Okay, sorry. Now, so here there is a, this is a rigid body, and in this rigid body what we are doing, we are replacing the rigid body, the rigid link, into the two masses. One is your m1 and another one is your m2. Now let us go for the two force member and three force member concept. What is two force member? For any element which has a hinged support or a pinned support at the both ends, and it carries no load in between, then it is called a two force member. Examples are cables, columns, strut, hangers, braces, and there are numerous examples also. And if only two forces acts on a body that is in equilibrium, then they must be equal in magnitude, they must be collinear, and they must be in opposite sense. If they have equal magnitude, they are collinear, they are opposite in sense, then it is known as a two force principle. Or, and the member which is pin jointed, see here, at this end, at this point, at this connection, and at this connection, it is hinged or pin jointed. Okay, and between this there is no load, it carries no load in between them, then it is known as a two force member. Now what is a three force member? If three non-parallel forces acts on a body in equilibrium condition, then it is known as three force member. Now here you can see that if such type of member, this three force member, if such type of member is in equilibrium, the forces are neither parallel but they must be concurrent. That is the important concept. A three force member is of generally it is an element which has a single load and two reactions. There will be two reactions and there will be a single load. If this condition is satisfied, then it comes under the category of three force member. Now, let us move to the center of percussion concept. Center of percussion means what? It is the point where there is an impact but it produces no reactive shock. For example, if we will take an example of a cricket bat or a baseball bat, each and every student plays cricket. So tell me, and please, it should be not a one-way communication. One of you can give me the answer. I will wait for it. So in cricket, what happens if a batsman is batting? Okay, if a batsman is doing the batting and if it strikes the ball, at one time what happens? The impact is so proper that the ball reaches to an extent level of length or it goes for a six, for example. The impact is so nice, so beautiful, so proper. Those who have played the cricket, they have imagined this example. Similarly, at one point what happens? A bowler has bowled the ball, the batsman has struck the ball, but the impact is so dangerous that the whole handle of the bat vibrates and sometimes we release the bat. So now tell me students, such type of condition you have seen while playing the cricket? Yes or any student? You have faced such type of condition? No one has faced? Yes? Yes? Dharmendra Kumar, Vinay Patle, Palash, Suraj, any student? Harsh Pandey, Pradeep? Yes, no one is ready to share their experience regarding center of percussion. Okay, then let us continue. My voice is, am I audible na properly and screen is visible to you, please?
Yes, sir. Yes, sir.
Okay, okay, let us continue. So basically what happens at one region in the bat or in the baseball, there is a sweet spot and that sweet spot is known as the center of percussion. If the ball strikes the bat at that sweet spot, no reactive shock is produced. Why no reactive shock is produced? Because translational and rotational motion get cancelled out. So, an impulsive blow is developed at a certain point and that point is known as the center of percussion. Generally, this is the point at which no reaction force is being felt, the motion get cancelled and It obeys the conservation of angular momentum and the conservation of momentum concept. That is your linear recoil concept and the rotation about center of mass concept. So, in general term, in a state briefing term, I can say that center of percussion is a point where no reactive shock is produced because all the motions get cancelled out. So it is known as a conjugate point, and at this point maximum impact is produced when the ball hits the bat. So this is the concept of center of percussion, and generally center of percussion is below the center of gravity of your body, of the system means, for example, it is a bat or a baseball or any other pendulum or anything. The center of percussion position is just below the center of gravity. Now, so let us start with our analytical process. Here I have considered a single slider crank mechanism. Okay, and in this single slider crank mechanism at point P, this is your slider at, this is one position of the slider, and after some point, after some angle, the position of the slider is P dash. So for example, if this is the inner dead center and this point is your outer dead center, and let us assume that this crank, this is your crank, this is your crank, and C to P is your connecting rod. This will be your what? Slider. Okay. So when crank has turned through angle theta at a speed of omega radian per second. Okay. For example, in this diagram, we will assume that x is the displacement of the slider. Similarly, L is the length of the connecting rod, R is the radius of crank, theta is the angle of crank with respect to the line of stroke. This is your line of stroke. This is your line of stroke, and phi is the angle of inclination of connecting rod to the line of stroke PO. So if I will draw a very important equation, for example, let us consider this position of slider P. This is your C and this is your O. Okay. This angle is phi, this angle is theta, this is L and this is R. So if I will, this is P. If I will apply the sine rule, if I will apply the sine rule, then I can get the equation L sine phi equal to what? R sine theta. This is known as the sine rule. Okay. इसको बोला जाता है sine rule, like this. This sine rule is very important while solving the problems of dynamic linkages of mechanism. Now let us move further. Here, let us consider that the slider has moved from P to P dash, or if I am moving the crank in clockwise direction, then it has moved from P dash to P. If crank is moving in anti-clockwise direction, it will move from P to P dash. So no debate in it. For example, the crank is rotating in clockwise direction. So when the crank will move, the slider will also move. and this is the displacement of the slider x. If I will differentiate displacement with respect to time, I will get velocity, and if I will differentiate velocity with respect to time, I will get the acceleration. So here we will just see the expression x double dot or a. So what we have to do, we have to see the expression of acceleration, we have to see the expression of velocity, and we have to see the expression of displacement x. Okay. Now also here let n be the ratio of length of connecting rod to the radius of crank. So L by R is the ratio. So this is the, just we will go through the expression. This is the expression for the displacement of piston. Now displacement of piston or displacement of slider can be expressed in terms of length of connecting rod also and radius of crank. In first here you can see displacement of piston is xp equal to L in the bracket 1 minus n square minus sine square theta by n plus r 1 minus cos theta. And similarly, this is your next equation. In this equation, you can see that here there is no need of connecting length of the connecting rod. So if L is not given, length of the connecting rod is not given, directly we can use the equation, and generally as n equal to L by R, okay, so we can use any of this equation for finding the displacement of the piston or displacement of the slider. Now this is the expression for displacement of piston. If we will differentiate this with respect to time, we will get the velocity. So this is the expression for velocity. We have differentiated the acceleration. You know how to differentiate it. Velocity dx by dt. Okay, so this is the expression omega r sine theta plus sine 2 theta upon 2 under root n square minus sine square theta. So generally what happens, the length of connecting rod is generally it is greater than the crank. In practical or practically we will see length of connecting rod is always greater than the radius or length of the crank. And if this condition is satisfied, it means that always the obliquity ratio will be greater than 1. And if the obliquity ratio, that is the L by R, is always greater than 1, then it means that the sine theta will always be less than 1. Simple. And if the sine theta is always less than 1, as the obliquity ratio is greater than 1, then I can directly write the velocity of piston as omega square sine theta plus sine 2 theta upon twice n. Sine square theta term will become 0, and if sine square theta term is approximately equal to 0, then it will be just 2 into under root n square and will be out of the root, so it will be just twice n. So here this term becomes 0, so it will be 2 under root n square, so it is just twice n. And why sine square theta is 0? Because sine theta is less than 1. If sine theta is less than 1, it means that sine square theta, this term will be approximately equal to 0. So this is the expression for velocity of piston, and third is the expression for acceleration of the piston. Now, in acceleration, what we are doing? In acceleration, this is acceleration, that is differentiating velocity with respect to time. Now, acceleration on piston will be omega square r cos theta plus cos 2 theta by n. Here, student, you should be, here I have highlighted this point, okay? That is when crank angle theta is 0. When crank angle theta is 0, maximum acceleration will occur. Okay, so when theta is 0, this cos theta will be 1, cos 0 will be 1, and similarly this term will also be 1. So expression will be omega square r or r omega square 1 plus this term is also 1 divided by n. So this is your expression. Directly, if in the question it has been said that maximum acceleration is there, it means theta will be 0. And if theta will be 0, directly use this expression. And if it is a normal acceleration from 0 to 360-degree, okay, at a certain instant we have to determine the magnitude of acceleration, then we will use a normal equation omega square r in the bracket cos theta plus cos 2 theta by n. Okay, now when it is the angular velocity omega and angular acceleration alpha, so angular velocity is your omega cos theta by n. This is your angular velocity, and angular acceleration is minus omega square n sine theta. What we have done, this is the expression for angular velocity. We have differentiated this expression with respect to time, so we have get this answer minus omega square n minus omega square by n into sine theta. So these are the expressions for velocity of piston, displacement of piston, acceleration of piston, angular velocity, okay, of connecting rod CR, and angular acceleration of connecting rod. So these 4 to 5 expressions are needed for solving the dynamic linkages problem. Now let us move to the force analysis. Now in force analysis, what we have to do generally, see, in a reciprocating steam engine, there are various factors, various forces which have to be considered because all these forces, all these weights are acted on the engine. So, the various forces which are acted on the engine may be the reciprocating masses weight, it may be the weight of the connecting rod, then the gas forces, then forces due to friction. Similarly, your inertia forces due to the acceleration and retardation of the engine elements. Okay, so there are number of reasons, there are various reasons through which number of forces are acted on the engine. Let us say some forces, the basic forces, that is your driving force, it means the piston effort. Piston effort means what? Because of the combustion, the thrust which is acted on the piston, that is known as the piston effort. Then the thrust force, then the thrust on the sides of cylinder, crank effort or effort of the crank, and the bearing thrust. So these are the 5 basic efforts which are acted on the system. Now let us see turn by turn. Force analysis, and the first is your C. I will cover all this point. Piston effort, then force, then thrust, then crank effort, thrust on bearings, and then we will go to solve the gate numericals. So now the first is your piston effort. As I have told you, see this figure. In this figure, this is your cylinder. Okay, this is the piston, this is your connecting rod, and this is your crank. This angle is theta. Okay, crank, connecting rod, piston, cylinder, like this. Okay. Now, what happens? As I have told you, piston effort is your net or effective force applied on the piston. For example, because of the combustion, due to the combustion, the gases strike the piston, piston moves forward, crank rotates. Okay. For example, this is the condition. Now here on the piston, the total force or net force which is acting is the piston effort. Now, piston effort depends upon three parameters. One is your pressure force, one is your friction force, another one is your inertia force. If we will consider these three parameters, pressure force, friction force, and inertia force, we will get the total net force which is acted on the piston. So, generally, what happens during the first half of the stroke, that is during for example, when the crank moves from 0 to 180 degree, when the crank moves from 0 to 180 degree, the reciprocating masses accelerates, उनकी स्पीड बढ़ती है. And if the reciprocating masses accelerate, the inertia forces tends to resist it, and we will get the net force on piston, which will be in a decreased pattern. Similarly, during the later or second half of the stroke, that is from 180 to 360 degree, reciprocating masses decelerate and inertia forces again it will oppose it. And here the effective force on the piston will increase. So during first half, net force is reduced. Why? Because reciprocating masses are accelerating. And during second half, the net force is increased. Why? Because reciprocating masses are decelerating. So let us see that in force analysis, what is pressure force, what is friction force, and what is inertia force. Here we have studied about the concept of net force कि भैया net force increase कब हो रहा है piston पे और net force reduce कब हो रहा है piston पे. Now let us see what is the pressure force, friction, and inertia force. So I have drawn a free body diagram of a piston. Okay. Now you can see this is my piston. Here there will be a piston rod. I will draw another diagram like this. Okay. For example, crank is on the right side. I will draw like this. This is my crank. This is my piston rod. Now tell me that this is the piston. Let us consider the diameter as d to the left. Similarly here, this is your piston rod. Let us consider this diameter d and this is capital D. Now for example, the pressure which is acting on the open side is P1 and the pressure which is acting on the right side is P2. This pressure is because of the gases which are striking the piston on either side. So here the area will be pi by 4 d1 square. एक पूरा एकदा है pi by 4 d1 square. And here as if I will draw its cross sectional diagram, it will be somewhat like this. Okay, so this is the area. So this is capital D and inner one is small d. So area will be pi by 4 d square minus d square. So the gas force will be, total gas force will be total area on right side minus total area on left side. So P1A1 as stress is what? Force into area. Similarly, force will be stress into area. Stress हटा दो तो it will be pressure into area. So it is pressure into area minus total force on right side. So P1A1, the total area, total force on left side is pi by 4 d1 square. On right side it is pi by 4 capital D square minus small d square. Capital D is the piston diameter and small d is the piston rod diameter. So this is the Fp is your gas force which is acting on both sides of the wall of the piston. Now let us come to the friction force. Now see here I have written friction force plus minus F. It means that पॉजिटिव एंड नेगेटिव साइन हैज टू बी कंसिडर्ड. अब सवाल ये आता है कि सर ये कब कंसिडर करना है ये पॉजिटिव नेगेटिव साइन. सो if you have properly listened the previous slide carefully, if you have listened the previous slide, I have explained you that during first half the reciprocating, yes, during first half the reciprocating masses accelerates and during next half reciprocating masses decelerate. So if reciprocating masses accelerate, net force decreases, accelerate, net force increases. So in the first half reciprocating masses increases, okay, and second half reciprocating masses decelerate. So when the crank, when the crank, okay, when the crank moves from 0 degree to 180 degree, negative friction force is considered. Why negative force? Because during this position, the net force on the piston is decreasing. So negative force. During second half, the net force on the piston increases. So we considered positive friction force. So the angle from 0 to 180 degree in that position minus F, from 180 to 360 degree in that position plus F. So we have sorted out the friction force also. Now let us go to the inertia force. Inertia force is equal in magnitude to the accelerating force but in opposite direction. So what is accelerating force? Mass into A. So what will be the inertia force? Mass into A. But the direction will be opposite. Okay. So mass into acceleration. This is mass. Instead of acceleration, I have substituted this equation. Okay. And instead of acceleration, हमने ये पूरा इक्वेशन यहाँ पर उतार दिया. Now what will be piston effort? Piston effort will be addition of all these forces. So first is your gas force, second one is your friction force, inertia force, sorry, I have written Fi. So second one is your inertia force. But as I have told you, inertia force and accelerating force both are same, but it is opposite to the accelerating force. That's why I have written here minus Fi. यहाँ पर भी देखो माइनस एफ आई क्योंकि एक्सेलरेटिंग फोर्स के ऑपोजिट रहता है. ओके, प्लस माइनस एफ अकॉर्डिंग टू दी थीटा यहाँ पर प्लस एफ रहेगा अगर 180 डिग्री तक है तो प्लस एफ, 180 से 3 माइनस एफ सॉरी, और अगर इफ फ्रॉम ड्यूरिंग सेकेंड हाफ इट विल बी प्लस एफ. So this is F minus Fi because inertia force. If you अगर आपको कुछ कंफ्यूजन रहता है इसमें तो यू कैन ऑल्सो राइट दिस एज एक्सेलरेटिंग फोर्स. यहाँ पर आप पहले से यहाँ माइनस साइन लिख दो, तो इट विल बी माइनस एम आई, इट विल बी माइनस एम, तो फिर ये साइन आप यहाँ, बट यार फिर क्या हो जाएगा यहाँ पर बेटा, प्लस हो जाएगा. एफ पी प्लस एफ आई, तो आप वो माइनस सब्सटीट्यूट कर सकते हो, अदरवाइज देर इज नो हार्म इन इट. ओके ना. And the third one is your piston effort. So जब हम तीनों को कंसिडर कर लेंगे तो we will get the piston effort. Now see here, here piston effort is Fp minus Fi inertia force plus minus F plus minus mg plus minus mg. अब ये सवाल आ गया कि सर यहाँ पर इक्वेशन अलग है. Here there is, and this equation is, so which equation we have to select? Yeah, why this plus minus mg has come? So students, whenever the engine is horizontally placed, for example, the line of stroke is horizontal like this. This is your slider or piston. Okay, this is your crank connecting rod, and this is your crank. Here, see, this line of stroke is horizontal. At that time, we have to use this piston effort equation. Understood? Similarly, when line of stroke is vertical or the location of engine is vertical or there is a vertical engines, so in that case, weight of the piston or reciprocating parts are also act as a force, and therefore we have to consider it. And how? See, like this. Okay. Now see the location here. It is a vertical, line of stroke is vertical. Similarly, if this is the condition, plus mg, इसका उल्टा कर दो, like this. If this is the condition, minus mg. Okay, so this is the concept related to plus minus mg. Now let us move to the analysis part. Here, what we have done, as I have told you, see, huh, this is my piston. So the forces due to combustion which are acting on this piston, let that be F. This is F force. Because of this force, there will be some force or thrust along the connecting rod. For example, if piston will move in this direction towards right, the thrust will be here. If piston is moving towards left, the thrust will be here along the connecting rod. Okay, so Fc is the thrust along the connecting rod. Similarly, the normal thrust to the cylinder walls or thrusts on the side of the cylinder or normal reaction on the cylinder walls be Fn. So this is your Fn. This is the normal force. This is your Fn, and this is your connecting rod force, a thrust along the connecting rod. So see this. If I will draw the free body diagram by considering F, Fn, and Fc, so it will be like this. Along the horizontal, this is your F. Along this connecting rod, this will be your Fc, and this will be your Fn in such a way that this angle will be what? Beta. And if I will use trigonometry, so what is cos beta? Cos beta will be adjacent upon hypotenuse. Okay, adjacent will be your F and hypotenuse will be your FC if this is your triangle. So what is cos beta? Cos beta will be F upon FC. So what will be Fc? Fc will be F upon cos beta. And F upon cos beta is your force or thrust acting along the connecting rod. And it is also known as connecting rod force. Now second is your Fn. Fn is your thrust on the sides of cylinder. The force which is acting on the sides. Normal direction or normal reaction on the cylinder wall, which will oppose the line of stroke, which will be not opposed, which will be perpendicular to the line of stroke. That will be your normal thrust or normal reaction. And that too, if I will use simple, I am taking sine beta. What is sine? Opposite side upon your hypotenuse. So your Fn will be, I've just used the trigonometry. And if I will use the trigonometry, this is F, this is your Fn, and this is your F. Okay, I will write here F. This is your F. So sine beta will be opposite side upon F, hypotenuse. So Fn will be Fc sine beta. And instead of Fc, if I will substitute F upon cos beta, so F sine beta upon cos beta will be tan beta. So if you know this free body diagram, there is no need to mug up the relations. Directly by using trigonometry, you can solve it. Now, again, next. Next is your crank effort and the thrust on the bearing. Now, crank effort means it is the force which is applied at the crank pin and which is perpendicular to the crank. This is your crank pin. So the force which is perpendicular to the crank, this force is known as Ft, and Ft is termed as crank effort. And what Ft does? Ft will give the required turning moment on the crankshaft. It is very simple, students. When this force, this piston effort will act on this piston will move in forward direction, this motion will be transmitted to the crank through the coupler and this crank will move. And when this crank will move, that is, it will rotate, a perpendicular thrust will be provided at the crank pin, and this perpendicular load with respect to the distance is nothing but your turning moment torque. So what is torque? Ft into R, and Ft is your crank effort, as I have told you. And the next one is your thrust on the bearing. The thrust on the bearing is this one. This is the thrust on the bearing. And this is your Fr. It is denoted by Fr. You can see this thrust on the bearing is along this crank, along the crank. So actually it is the component of Fc, okay, along the crank in radial direction, and it produces a thrust on the crankshaft bearings. So that is your Fr. So Ft equation is also Ft is Fc sine theta plus beta. Ft equal to Fc sine theta plus beta. which is equal to f upon cos beta sine theta plus beta. And what is torque? Torque is the product of load into distance, tangential force into distance. And this is the your sine rule that I have explained you. Similarly, the thrust on the bearing sorry is equal to fc cos theta plus beta, f upon cos theta plus beta. This is the expression. So my dear student, if you want to attempt the questions on dynamic analysis of linkages, you should know the concept of this approximate analytical method. This relation you should know, and similarly in force analysis you should know all these forces which are acting on the mechanism. Okay, if you are comfortable with all these equation, then any problem you can solve related to this topic. So let us take some examples. The first example is a slider crank mechanism is shown in figure. Okay, at some instant the crank angle is 45 degree. First of all, you should know that the crank angle, this is your crank. Okay, this is your connecting rod. Okay, here 40 Newton is the force or effort. And this angle is your theta. And this angle, connecting rod angle, is your beta. You have assumed theta as the angle of crank and beta is the angle of connecting rod. And at some instant, theta equal to how much? 45 degree. Similarly, the length of crank is 30 mm. R is the length of crank and L is the length of connecting rod. So, length of crank is 30 mm. Length of connecting rod is 70 mm. We have to ignore all the gravity, friction and internal forces. And what we have to do? We have to determine the crankshaft torque. Crankshaft torque means, for example, if this system is moving in this direction. Okay, so this is the crank pin. So perpendicular to the crank here, this is your FT. Okay, and this is at 90 degree. So what will be the torque? Torque will be Ft by R. Torque will be what? Ft by R. और Ft क्या है बेटा? तो Ft है आपका F upon cos beta, then sin theta plus beta multiplied by your R. ये आपका इक्वेशन है. Okay, so if we want to find, see here, what is Ft? Ft is Fc sin theta plus beta, which is equal to F upon cos beta sin theta plus beta. Now, if we want to find out the torque in Newton meter, we should know each and every parameter. So what is F? Acha, any of you can me tell me that which parameter has to be find out of this? Any student? Yes. Which parameter has to be find out? Surat, Savarkar, Palash, Harsh, any one of you? Prajwal? Okay. Now, see here. We don't know beta, but as I have told you, What is the relation? As L sine beta equal to what? R sine theta. So this implies L is how much? 70. Sine beta equal to R is how much? 30. Sine 45 degree. So from here we can find what? Beta. That is the angle of connecting rod with respect to the line of stroke. And it is 17.6406 degree. If beta is known, then what is torque? F is 40 upon cos beta 17.6406 degree multiplied by sine theta is 45 degree plus beta is how much? 17.6406 degree into R. Here we have to substitute R in meter. Okay, not in mm, otherwise torque will be in Newton mm. ओके, यहाँ पर बोला गया है कि फाइंड द टॉर्क इन व्हाट? न्यूटन मीटर. तो सब्स्टिट्यूट आर इन न्यूटन मीटर, नॉट इन एमएम. ओके, and here the answer will be somewhat 1.1183 Newton meter. So this is the answer. Now let us move for the next question. A slider crank mechanism has slider mass of 10 kg. Okay, there is a slider crank mechanism like this. This is the line of stroke. Here, let us consider this as a fixed point, this as a crank, and this as a slider. Okay. So we have drawn a slider crank mechanism. Now the question says that slider mass of 10 kg. So this is your slider. So mass of slider equal to 10 kg. Stroke is 0.2 meter. Stroke is 0.2 meter. If stroke is 0.2 meter, I am giving you one relation that radius of crank is always half of the stroke. Okay. So radius of crank will be 0.1 meter. If you don't know this relation, you will not be able to solve. Then the primary inertia forces of the slider are partially balanced by a revolving mass. Okay. Inertia forces of slider are partially balanced by a revolving mass of 6 kg at the crank. Okay. So here there is a mass. Okay. And this balance mass is, I will write MB. This balance mass is 6 kg. And what this balance mass is doing? It is balancing the primary inertia masses, inertia forces of slider. And this is R, so this distance is also R. When the crank angle with respect to slider axis is 30 degree, okay, if this angle is 30 degree, the unbalanced force normal to the slider axis, normal to the slider axis, so here this will be your unbalanced force. For example, this is your unbalanced force F, unbalanced, and this unbalanced force we have to find out, and this unbalanced force is normal to the axis of the slider. This is your slider axis, and this force is perpendicular to the slider axis. So basically, what is unbalanced force? F equal to what? In the balancing you have studied, it is mr omega square, and we have to take the vertical component. So it will be what? Sine theta. There will be two component, cos and sine. We have to take the vertical component. So vertical component will be sine theta. And this will be your, if this angle is theta, this is also theta. So this angle is 30 degree. तो ये जो है बेटा, इसका ये फोर्स हो गया F. इसके दो कंपोनेंट, ये वर्टिकल और ये हॉरिजॉन्टल. Okay, horizontal will be mr omega square what? Cos theta. And this is vertical, that is your mr omega square sin theta. हमको क्वेश्चन में क्या बोला? We have to determine this unbalanced force. So here your answer will be what? Your answer will be mass is 6, radius of rotation tell me 0.1, omega is given, yes, 10 radian per second. Omega is given 10 radian per second. So 10 square multiplied by sine theta. So sine theta is 30 degree. So unbalanced mass is equal to 30 Newton. So this is your answer. Okay. Now, for example, okay, let us move to the next question. For example, this is the question. A slider crank mechanism with crank radius 60 mm. Okay. Now, a slider crank mechanism with crank radius 60 mm. So radius of crank is 60 mm. Length of connecting rod is 240 mm. Uniform speed omega is 10 radian per second. The speed of the slider, that is we have to determine speed of the slider, velocity of the slider piston. And the angle between crank and connecting rod is 90 degree. So for example, this is your crank, this angle is 90 degree, and this is your slider. Okay, this is radius and this is L. ठीक है, ये एंगल हो गया आपका थीटा. Now what we have to determine? We have to determine the velocity, speed of the slider, that is your piston. So tell me, what is the equation for velocity of piston? It is omega r sin theta plus sin 2 theta upon 2 अंडर रूट n square minus क्या? sin square theta. This is the expression omega r sin theta plus sin 2 theta upon 2 n n square minus sin square theta. Here what is n? N is L by R. N क्या है? N है L by R. L is 240, R is 60, so it will be what? 240 by 60 somewhat 4. ओके. सिमिलरली हमको थीटा चाहिए. अगर हमको थीटा चाहिए बेटा, तो आर और एल है, तो हम निकाल सकते हैं थीटा. कैसे निकाल सकते हैं? इफ आई विल यूज tan theta. So what is tan theta? It is L by R. So from here 240 upon 60. So theta will be uh, 10 inverse 240 by 60 to 75.9637 degree. This is your theta. Okay. So now tell me if I will substitute all these values. Vp equal to omega 10 R 60 mm 60 into 10 raised to power minus 3 in meter sine 75.9637 degree plus sine 2 into 75.9637 degree, the whole divided by twice under root n square, that is 4 square, minus sine square theta 75.9637 degree. So from here we will get Vp equal to what? 0.6184 meter per second. So this is your answer. So see, directly we can put the value and we can get the answer. Only thing is that you should now let us see this question. A slider crank mechanism with crank radius 200 mm and connecting rod length 80 mm is shown. Okay. The crank is rotating at 600 rpm in counterclockwise direction. In the configuration shown, the crank makes an angle of 90 degree. So this is your radius, this is your length, this angle is theta, this angle will be what? Beta. Okay. This is your force F. And what we have to do? We have to determine the torque. Again, torque. What will be torque? We have to determine torque. For example, if this is the direction of thrust, it means this is the direction. So this is your Ft. So torque is Ft into R. So T equal to what is Ft? Cos beta sine theta plus beta multiplied by what? R. अब रही बात यहाँ पर कि सर सब कुछ तो है, बीटा कहाँ से लोगे? तो मैंने आपको रिलेशन बताया ना एक, दैट रिलेशन इज L sin beta equal to R sin theta. So from here find out beta, it is 14.47 degree. Substitute here each and every value, you will get answer 1. आंसर काय में चाहिए? किलो न्यूटन पर मीटर. So substitute the value of F as 5 kilonewton. This value of R in meters. Understood? So answer will be 1 kilonewton meter. This will be the answer. Now next question. Consider a slider crank mechanism with non-zero mass and inertia as shown in the figure. Now, which of the following plots uh, which of the following plot best resembles variation of crank angle theta versus time? There are 4 options and we have to assume that which is the best resemble. So note one thing, that the first plot is directly proportional. So in a slider crank mechanism, the angle with respect to time is not directly proportional. It can never be happen practically because of the losses, wear and tear, frictions. It cannot be simple harmonic, neither it can be a parabolic. It may be a somewhat approximate this nature. So this is the answer. Now, next question. In a certain slider crank mechanism, length of crank and connecting rod are equal. If the crank rotates with uniform angular speed of 14 radian per second and the crank length is 300 mm, the maximum acceleration of the slider is meter per second square. Now in this question, see, for example, here it has said that length L equal to R. If L equal to R, then what is N? N is L by R. Both are same, so N will be what? 1. We have to determine acceleration. मगर acceleration कहाँ पर किसका निकालना है बेटा? We have to determine maximum acceleration. And I have told you what? For maximum acceleration is occur when theta equal to 0 degree. See, maximum acceleration is at theta equal to what? 0 degree. So if theta is 0, directly your answer will be r omega square 1 plus 1 by n. Okay. So it will be acceleration equal to r omega square 1 plus 1 by n. Okay. So omega is how much? Omega is 14 radian per second. Crank length is 300, that is 0.3 meter. Okay. And we have to determine maximum acceleration. So maximum acceleration will be 0.3 multiplied by 14 square 1 plus 1 by 1, and the answer is 117.6 meter per second square. This is your answer. Now, the next is your problem. Consider the triangle formed by the connecting rod and the crank of an IC engine. So this is the free body diagram of a crank and connecting rod of an IC engine. Okay. Now, if the maximum area of this triangle occurs when crank angle is 75. Okay, for example, if this is my crank and this is my slider. Okay, and this is the line of stroke. And the question says that this maximum area of this triangle is when it will occur when the crank angle, when this angle theta equal to how much? 75 degree. And what we have to do? We have to determine the ratio of connecting rod length to the crank radius. Okay, we have to determine n. n is ratio of L by R. तो हमको ये निकालना है, ये रेशियो. यहाँ पर देखो बेटा, मैक्सिमम एरिया of this triangle occurs when crank angle is 75. Listen, you should know that for maximum area, for maximum area, the angle between crank and coupler, that is your connecting rod, अगर मैक्सिमम एंगल चाहिए तो दोनों मैक्सिमम एरिया चाहिए ट्रायंगल का, तो द एंगल बिटवीन क्रैंक एंड कनेक्टिंग रॉड should be always 90 degree. So that's why it has mentioned, okay, maximum area. इसलिए बोला है maximum area of this triangle. तो when maximum area will be obtained, when this angle between crank and connecting rod both are mutually perpendicular. So this angle is 90. If this angle is 90, then tell me what will be beta? Then beta will be
Hello, sir, you are not audible. Hello.
हेलो।
हाँ
सॉरी
सर,
फॉर,
please.
हाँ सर, ये नेट प्रॉब्लम आ गया था, तो आई हैव कनेक्टेड विथ माय फोन नाउ। ओके, अगेन आई एम प्रेजेंटिंग माय स्क्रीन। ओके, so let us continue. Sir, my voice is audible and the screen is visible,
Yes,
sir.
yes, sir,
So,
yes, sir.
okay, okay. So let us continue. So, for maximum area, the angle between the crank and connecting rod should be 90 degree, as I have told you. So, how we can find beta? Beta will be 90 degree minus 75, which will be equal to what? 15 degree. Okay. Also, if beta is known to us as relation is what? L sine theta equal to R sine phi. This is the relation. And through this relation, we can find L by R. So L by R it will be somewhat 3.73. So this is the answer. So here we complete the dynamic force analysis of linkages. Okay. Now let us move. Let us try. I am again presenting my screen, and this will be the, we will try to complete it within half an hour, flywheel. Okay. So this is the flywheel. We will try to complete the flywheel topic within half an hour. Just go to the basic briefing of the flywheel. Now tell me, first of all, see the content of flywheel. We are just concentrating on the flywheel. First, a turning moment diagram. Second is your sorry, content. In the content it is what is a flywheel, then what will be the turning moment diagram, then how we will determine the maximum fluctuation of energy, how we will determine the coefficient of fluctuation of energy, then fluctuation of speed, then how energy is stored in flywheel, then punching press concept, and if time will proceed, I will go with some gate numericals. Okay, so let us start. 1 minute. Now, basically, what is a flywheel? Flywheel is a mechanical device which is used in machine. In machine, is it attached to a what? Crankshaft, and it serves as a reservoir. And we know that reservoir is what? Reservoir is the system which stores something. For example, it is a tank reservoir. It will store fluid. Okay. So here flywheel is a reservoir which stores excess energy. Now this excess energy is your kinetic energy, and this kinetic energy is stored during the period when supply of energy is more than the requirement, and it releases it during the period when requirement of energy is more than the supply. In this figure also, in this figure also, here you can see this is the flywheel, this is the crankshaft and is attached with the crankshaft. So generally flywheel stores the energy and release the energy as per the requirement. Okay, its application is in IC engines, internal combustion engines, then reciprocating, compressors, then pumps, crushers, punching machines, shearing machines, riveting machine, etc. There are various number of applications of flywheel. Now let us see, after going through the definition of flywheel, that it is used to store the energy and release the energy as per the requirement. Now let us move and see what is the turning moment diagram. It is important, turning moment diagram. Turning moment diagram is a diagram which is also known as a crank effort diagram, in which here, for example, this is your T theta diagram. On y axis turning moment is plotted, and on x axis crank angle is plotted. And here we get the, and within this area we get the turning moment diagram. Now in dynamic analysis that we have completed, in that topic we have seen that we have also find out the torque. So what is torque? So basically torque is Ft into R. Okay, and this expression, again this Ft in terms of Fp, it can be written as sine theta plus sine 2 theta upon 2 n square minus sine square theta. So basically this is the expression for the torque that we have studied in the dynamic एनालिसिस ऑफ लिंकेजेस. तो ये हमने पढ़ा है, अभी पढ़ा है हमने ये एक्सप्रेशन. एंड दिस एक्चुअली दिस इज turning moment. Application of turning moment diagram is that it helps us to design the dimensions and masses of the flywheel. Now let us see the turning moment diagram of a double acting steam engine. Okay, so first of all, see here the this is the turning moment diagram, and in this turning moment diagram, see the area is like this. 1 minute. The region is O, then F, O, A, F, G, H, B, then P, C, J, K, L, G, E. So these are the points. Before explaining you, I have located all these points. Okay, and this is your mean torque line. This is your mean torque line. So generally, in turning moment diagram, what we do, the inertia effect of the connecting rod is ignored. Sorry, is ignored while drawing the T theta diagram. Generally, we ignore it. Now observe this figure, this T theta diagram, and you will find that during outward stroke, this is T and this is theta. Just observe. Observe this figure and you will find that OGP. During outward stroke, this is outward stroke. This is your outward stroke. O, G, P. This is your outward stroke. Okay. And the turning moment diagram is maximum when the angle theta is somewhat closer to 90 degree. It is somewhat closer. Pi by 2 means 90. So turning moment diagram is maximum when theta equal to somewhat closer or up to 90 degree. Okay. And the turning moment diagram is minimum when theta equal to what? Theta equal to 180 degree. So this is 90 degree and this is 180 degree. This is first thing. Similarly, during return stroke, also during return stroke theta, you will find that the turning moment diagram is maximum in between 3 pi by 2, closer to 3 pi by 2, and it will be minimum at 2 pi. So this is first point. Second point is that here the turning moment diagram against which the engine work is being shown to you. And here we can also see that the turning moment diagram area is directly proportional, or it is proportional to the work done per revolution. And why it is proportional to work done per revolution? As work done is the product of turning moment diagram and the angle theta. Okay. So now let us see that during point OA to point OB, I will just rub this. Okay. ठीक. So during from point OA to OB we will see. Okay. Now see from OA to OB. You will find that during point OA to OB, the work done by the engine is triangle is the area AFHB. This is the work done. This is the work done by the engine. During point OA to OB, and लिखा भी हूं मैंने, during OA to OB, the work done is area AFHB. This is the area. Okay. It means that the work done against the resisting torque is AFHB, and this will be your FGH. This will be your excess torque. This is your excess torque. So what is happening when the position is from point A to point OB? Okay. At this point, the work done against the resisting torque needed is AFHB, and but the actual work done which is being performed is AFGHB, where FGH is the excess work. So this excess torque in terms of kinetic energy will be stored in the flywheel. So in this position, what will happen? The speed will be increased and flywheel will store the energy. Similarly, also during point OC to OD, there will be excess work. As there is excess work, speed will increase and flywheel will store the energy. अब excess work कैसा है? तो ये देखो, excess work का मतलब क्या हो गया? जब O से C to OD point है, तो we just need this area below the mean line. हमको सिर्फ ये एरिया चाहिए, इतना वर्क डन चाहिए. But the system is area of the system is CJKLD. This is the total work done. और रिक्वायर कितना है? CJLD. This is the requirement. Okay, so what is the excess? Excess JKL. This is the excess. So this excess will be stored. This excess energy will be stored in the flywheel. Similarly, during point OB to OC, OB to OC. So now you will find, see here, during OB to OC, this is the requirement. Below the mean torque line is requirement कितनी है बेटा? BHJC. This is the requirement. ये requirement है. मगर you will find that only this amount, only HPJ, only this here from which point? From OB to OC. So here the work done is needed for external resistance. तो हमको पूरा वर्क डन होना बी एच जे सी, मगर हमको कितना मिल रहा है एच पी जे. सो ये जो है ये दिस एरिया, this remaining this remaining area, this is the needed work for external resistance. So more work has been taken from engine, that is produced. So loss of work is made up by the flywheel, that area region, and in that area region the loss of work is made by the flywheel, which gives some of its energy and speed decreases. Okay, so you can see that the maximum speed is at A to B and at C to D, and the minimum speed at B to C and D to A. So fluctuation of speed is the difference between maximum and minimum speed. For your understanding point of view, see, during first outward stroke, AFGHB is the total area. We need AFHB. So FGH is the excess energy which is stored. खत्म हो गई बात. Then BHGC is the total requirement, but HPJ is done. This requirement is only available. So here we have to complete HBP and JCP work done requirement. So this is been taken from the excess energy. So this process is been followed. Now for engine fluctuation of speed, there are two types of cycle. One is intra cycle, another one is your inter cycle. Now inter cycle means, for example, if the speed has to be maintained over one cycle, it is known as intra cycle. Take the example of IC engine. Okay, and if the speed is maintained for a range of cycle, then it is known as intercycle. Take the example of a power plant which is operating throughout the day. During there are number of shifts: first shift, general shift, A shift, B shift, C shift, and during each and every shift the power plant is operating. Generally night shift, the requirement is less, but in the day hour the requirement is more. So over a range of cycle, we have the speed has to be maintained. So when the speed has to be maintained over a range of cycle, it is known as intercycle, and when the range of speed is maintained over one cycle, it is known as intracycle. For example, one power stroke is completed in 2 revolutions of crankshaft. One power stroke is completed in 1 revolution or 4 revolutions of crankshaft. So the cycle is completed during one or two stroke engine or in 4 stroke engine. So this is the category of intracycle. Now let us see the T theta diagram of a single cylinder 4 stroke engine. As we know that in single cylinder 4 stroke engine, one power stroke is completed in 2 revolutions of crankshaft, that is 720 degree. So let us for example say 0 to 180 degree is your suction stroke. From 180 to 360 degree is your compression. Then from 360 to next is your expansion, and from expansion from 3 pi to the 4 pi, that is your 720 degree, it is your exhaust stroke. So these are the 4 stroke during suction. For example, if it is IC internal combustion engine, okay, and it is a spark ignition, air fuel mixture will be inducted inside the cylinder. Okay, and if it is a injector type, then diesel, and only the uh, air will be inducted inside. So we are not going with the power engineering. We are just assuming that during suction stroke, air fuel mixture is inducted inside the engine cylinder. During compression, that air fuel mixture is compressed. Then during expansion, power stroke is completed, and the last one is your exhaust. So now what happens during suction stroke? The pressure inside the engine cylinder is less than the atmospheric pressure, and as a result of which there is a negative loop which is formed. Negative loop means what? For example, this is the negative loop. Below this line, below this mean torque line, it is negative loop, and above this mean torque line, it is positive loop. Okay, so generally what happens during suction stroke, negative loop is formed. Negative loop means power is supplied to the engine. Similarly, during compression stroke, again a large negative loop is formed because in compression stroke, work is done on the gases, as a result of which power has to be supplied to the engine. Then during compression stroke, it is a combustion process takes place, as a result of which gases expands and work is done by the gases. It means that a large positive loop will be formed. Large positive loop means power is developed by the engine. And the next one is your exhaust stroke. So during exhaust stroke, work is done on the gases. Therefore, a negative loop is formed. It means that power is supplied to the engine. So this is the single cylinder four stroke engine concept. Now, here only two things are important, positive and negative loop. So positive loop is the power developed by the engine, and negative loop is the power supplied to the engine. That is the work is done on the gases. Positive loop gases does the work done. In multi-cylinder engine, actually, in multi-cylinder, there are number of cylinders, and all the T theta diagram of each and every cylinder is incorporated. And after incorporating it, we get this such type of a T theta diagram. So generally, what happens for engines with more than one cylinder, the total crankshaft torque at any instant is given by the sum of the torques developed by each cylinder at that instant. So basically, in multi-cylinder turning moment diagram, the turning moment diagram of each cylinder is obtained separately, and then all the turning moment diagrams are integrated or superimposed over each other with saying some starting point shifted to the phase difference of angle between the respective crank positions. Now determination of maximum and maximum fluctuation of energy basically. So maximum fluctuation of energy means the difference between maximum energy and minimum energy. So this is the T theta diagram. T theta diagram. Here, for example, let at this point energy is at A, at this point B, at this point energy D, E, F, G. Okay, so let the energy, this is the T theta diagram for multi-cylinder engine. Let the energy in the flywheel at point A equal to what? E. Then the energy at point B will be what? Energy at A plus this area. So above the mean line it is positive, below the mean line the area will be negative. It is positive, it is negative. This is positive and this is what? Negative. So if energy at point A equal to E, the energy at B will be what? A plus A1. And here the energy is E. What will be energy at C? Energy at C will be energy at A, that is E, plus energy at B, that is A1, and energy of this region, that is minus A2. D की बात करेंगे तो E plus A1 minus A2 plus A3. ई की बात करेंगे तो -A4, एफ की बात करेंगे तो +A5 लगा दो, जी की बात करेंगे तो -A6. So these are the energies at different point. And from this, see, for example, this is the energy at A, then B, C, D, E, F, G. इसमें से जो भी मैक्सिमम एनर्जी रहेगी और जो भी मिनिमम एनर्जी रहेगी, अगर मैं दोनों का डिफरेंस लूंगा मैक्सिमम और मिनिमम फ्लक्चुएशन ऑफ एनर्जी का, तो आई विल गेट द मैक्सिमम फ्लक्चुएशन ऑफ एनर्जी. So the difference between maximum energy and minimum energy is the maximum fluctuation of energy. Now let us go to the next definition, that is the coefficient of fluctuation of energy. So generally coefficient of fluctuation of energy is defined as the ratio of maximum fluctuation of energy with respect to the work done per cycle. Then what is coefficient of fluctuation of speed? The coefficient of fluctuation of speed is defined as the ratio of difference between maximum and minimum speed to the mean speed. Here n is the mean. N is your mean speed. Okay. Mean speed means n equal to n1 plus n2 by 2. So instead of n, I have written n1 plus n2 by 2, and 2 is shifted to the numerator. And what is coefficient of steadiness? So it is the reciprocal of coefficient of fluctuation of speed. Now energy stored in the flywheel. Here this is the very important expression, and generally in flywheel this expression is used. So now this is the flywheel having hub, rim, arm, radius r. Let m be the mass of flywheel, then k be the radius of gyration of the flywheel, then I be the mass moment of inertia of the flywheel. Okay, now what is the kinetic energy of the flywheel? So kinetic energy is half I omega square. Generally, see, linear it is half mv square, and for angular mass is moved to mass moment of inertia, and linear velocity will be changed to angular velocity. So here kinetic energy is half I omega square. And what is I? I is the mass moment of inertia, which is equal to mk square. So instead of I have substituted mk square into omega square. Now, as we have seen that fluctuation of energy means max difference between maximum kinetic energy and minimum kinetic energy. So for maximum, let omega 1 be the maximum speed and omega 2 be the minimum speed. So 1 by 2 I omega 1 square minus 1 by 2 I omega 2 square. So here omega 1 is maximum speed and omega 2 is the minimum speed. So it will be maximum kinetic energy and this will be minimum kinetic energy. So which is half into I. I have taken half I common. So it will be omega 1 square minus omega 2 square. Delta E half. Then I. This is in the form of a square minus b square. So a plus b, a minus b. Now what I have done here, I have instead of omega 1 plus omega 2 by 2. What is omega 1 plus omega can be written as omega 1 plus omega 2 by 2. ऐसा मैं लिख सकता हूँ. So here what I have done, omega 1 plus omega 1 plus omega 2, I have multiplied it by omega like this. This is 1 minute. This is omega 1 mean value now. Okay. So here what we have done, first of all, this is my omega 1 plus omega 2, this is omega 1 minus omega 2. So omega 1 minus omega 2 is there only, but instead of omega 1 plus omega 2 by 2, I have written omega because omega is the average of two speed. That will be omega 1 plus omega 2 by 2. Okay, then I have multiplied by omega. So if I will multiply it by omega to the numerator and denominator, so there are two steps. One step that I have skipped here is your uh, as omega 1 plus omega 2 divided by 2 equal to omega. तो ओमेगा 1 प्लस ओमेगा 2 अपॉन 2 ये बन गया आपका ओमेगा. ओके, आफ्टर दैट व्हाट आई हैव डन, आई हैव मल्टीप्लाइड बाय ओमेगा अपॉन ओमेगा. So it will be omega square I omega into omega, it will be omega square, and omega 1 minus omega 2 upon omega. This is your coefficient of fluctuation of speed Cs. So it will be I omega square Cs. Okay, and I is what, mk square omega square Cs, and I also write this equation as E equal to what, I omega square half I omega square. So instead of I omega square I can write what, I can write twice E. So instead of I omega square, I have written what? Twice C. So these are the relation, very important relations related to your. Now let us solve one problem. In this here, a flywheel connected to a punching machine supply energy of 400 Newton meter. So, sorry, energy is 400 Newton meter. Angular speed is how much mean? 20 radian per second. And total fluctuation means what? This is the mean like this. This is maximum, this is minimum, and this is mean. CS. So here plus 2% and here minus 2% fluctuation. So total fluctuation will be how much? Total fluctuation will be मीन के ऊपर +2 जा रहा, मीन के नीचे 2% जा रहा. माइनस साइन ओनली मीन्स बिलो मीन लाइन, प्लस साइन मीन्स अबव मीन लाइन. तो टोटल इज 4%. So here your CS will be total 4%. That is 0.04. Okay. And what we have to determine? We have to determine I. So as we know that delta is what? Delta equal to I omega square CS. आपके पास डेल्टा ई है 400, आपको आई निकालना है, आपके पास ओमेगा है 20 का स्क्वायर और सी एस है 0.04. तो बेटा यहां से आंसर कितना आ जाएगा? 25 kg मीटर स्क्वायर. नाउ लेट अस मूव फॉर दिस प्रॉब्लम. ये व्हाट द क्वेश्चन सेज? द क्वेश्चन सेज दैट the maximum fluctuation of kinetic energy in an engine has been calculated to be 2600 joule. So delta is how much? 2600. And speed is 200 rpm. N equal to average speed. Okay, if n is 200 rpm, then omega will be 2 pi n by 60, and it is somewhat 20.94 radian per second. Now after that, the polar mass moment of inertia we have to determine, and CS is plus minus 0.5%. So plus minus 0.5% means twice into 0.5. That is your 1%. Okay, that is 0.01. Again, what is delta E? I omega square CS. तो बेटा आपको ये मालूम है 2600. आपको I निकालना है. Omega is 20.94. The whole square. CS is 0.01. So from here you can find I. So I will be 592.95 kg meter square. Now the last problem, I will take this as the last problem, then we will end our class. Okay. Now in this problem, torque and angular speed data over one cycle for a shaft carrying a flywheel are shown in the figures. Now what we have to determine, again, generally see in each maximum number of problems you will find you have to determine the moment of inertia. Okay. And for determine the moment of inertia, equation is delta E equal to what? I omega square CS. ओके. अब देखो बेटा यहाँ पर, अब यहाँ पर देखिए फ्लक्चुएशन निकालने के लिए इफ वी वांट टू डिटरमाइन व्हाट आई, सी देयर आर टू डायग्राम, वन इज योर टी थीटा डायग्राम एंड वन इज योर एंगुलर स्पीड डायग्राम. सो एंगुलर स्पीड डायग्राम की मदद से देखो, एंगुलर मैक्सिमम स्पीड इज हाउ मच? दिस इज योर मैक्सिमम स्पीड एंड दिस इज योर मिनिमम स्पीड. तो एवरेज स्पीड कितना हो जाएगा? ओमेगा 20 प्लस 10 बाय 2. तो 30, इट विल बी समवॉट 15 रेडियन पर सेकेंड. ये पहली चीज हो गई. नाउ व्हाट इज फ्लक्चुएशन ऑफ स्पीड? फ्लक्चुएशन ऑफ स्पीड इज मैक्सिमम स्पीड minus minimum speed divided by mean speed. So maximum is 20, minimum is 10 divided by 15. So CS will be how much? 0.67. ये भी मिल गया आपको. ठीक है. अब ये जो डायग्राम है टॉर्क का, यहाँ पर देखो मैक्सिमम फ्लक्चुएशन आपको निकालना है, डेल्टा ई. फ्रॉम दिस डायग्राम वी विल गेट व्हाट? फ्लक्चुएशन ऑफ एनर्जी. So fluctuation of energy here, this is the fluctuation of energy, delta E. So this fluctuation of energy is actually a rectangle and this is the base. तो base का कितना है? Pi minus pi by 2. This is the base and this is your height. So height is how much? 3000. So answer is somewhat 1500 pi. Okay. Now let us go to the solution. And what is delta E? I omega square Cs. So delta E is 1500 pi. We have to find I. Omega is 15 square. Cs is 0.67. So from here mass moment of inertia is 31.25 kg meter square. So here we have taken two to three problems related to flywheel also, and like this you can solve number of problems. Okay. Only thing is that you should know the derivation related to the maximum fluctuation of energy, and if you are capable and if you have studied properly regarding the derivation, then you can solve the numericals related to flywheel also and also related to the uh, dynamic analysis of linkages. So that is from my side. If you have any question, please ask me. And Vishwajit sir, now you can.
Yes, sir. Do you have any doubt? हेलो, किसी को कुछ पूछना है बेटा?
No, sir.
Okay, I think there
Hello.
is no doubt from the student side, sir. हाँ, okay. हाँ, कोई पूछ रहा था डाउट?
Yes, Suraj Savarkar.
No, sir. Problem नहीं.
Okay.
कोई डाउट है सूरज?
नहीं, sir.
If there are no doubts, can we end the class, sir? Vishwajit sir?